Okay,
We're here, Lars.
The idea was for Banned Books Week that they were doing stuff on Harry Potter, and I said I could explain the physics behind how to make any device from Harry Potter, well, how to try to make it exist in the real world without magic. Some of them we can't quite get there, but most of them we can get close. And so my idea was I was going to do it by talking about whichever one people wanted, but people's is you three. So I'll try to explain any of the things you want, but you have to tell me which of the many you three want me to explain of any device in Harry Potter. Oh, I have port keys. Of course I have port keys.
Yeah, port keys.
Port keys is going to be part of many things at the same time. Port keys is going to be explained the same way as any teleportation device, which there's a whole bunch of those. Also, anything that's bigger on the inside, like the Weasley's tent, will use the same logic. Theoretically, forms of teleportation or space bending, aka bending space to hold more space within, is all possible theoretically. This is one of the most complicated ones I have a description for, because you have to understand Einstein's theory of general relativity, which I can explain in a very, very short version of. But
hit it.
Yes. Okay. Here's the logic. How to make teleportation possible in the real world. Or bigger on the inside possible in the real world. General idea is, as I said, I got to explain this theory to make it sense, is light is affected by gravity. Which doesn't make sense. Because Newtonian gravity says, I know, is that gravity affects things with mass. But what Einstein pointed out is if you were standing there if you were in an elevator and you shined a light, and let's say this elevator, it's like I can't really do an elevator. It's more a space elevator, but let's say you're in a box in space, accelerating upwards at the same rate that gravity normally pulls you down. You're accelerating upwards at 9.8 meters per second squared. Gravity normally pulls things down at 9.8 meters per second squared. And you shine a light. Logically, the light should come straight out. But what happens when the light leaves your light switch like this, you're moving upwards when the light's coming straight out. And because you're moving upwards, the light's going to hit lower than where you shined it, because you moved up while the light came straight out. Logic make sense on that? Okay. If you're in a box in space moving at 9.8 meters per second squared, you would not be able to tell the difference between that and standing on Earth. That to you, they'd be the same. It's the idea of relativity. So what that means is, since this is identical to you just standing on Earth and shining a light, gravity must affect light, which goes against everything we knew about light. I actually got ahead of myself. I should probably read what I had in my slides. So yeah, you can't tell the difference between these two cases, between this and the elevator going upwards. So gravity must affect light. Now we know gravity only affects things with mass, and light has no mass, or at least we knew, which what this meant is Einstein said that everything we knew about gravity must be wrong. Funny enough, the math still works for Newtonian gravity, but the theory behind it's 100% wrong, is what Einstein said, because of the fact gravity affects light. And that's when Einstein went crazy. He made two postulates. The one is that the laws of physics are true in any reference frame. That one's not that crazy, that no matter what, the laws of physics are held true. And also that at any point, gravitational field is the same as an acceleration frame of reference. What that means is this idea of the elevator. That if you are accelerating upwards at 9.8 meters per second or standing on Earth, it's the same. Making those two assumptions, which that's not the crazy part. Those are pretty logical. What he proposed was the idea of the curvature of space-time. This is where it gets nuts, and she gets uncomfortable. The logic is gravitational force does not exist. We feel gravity, but it is not a force as we picture it. The more massive something is, the more mass it has, space itself bends around it. This is kind of like a drawing of it, this picture of the Earth in the field. The classic thing is, I'll do the classic one on the next slide. And the general idea is that light always moves in a straight line. It's just what we define as a straight line changes. And in fact, all objects are always moving in a straight line. Just once again, straight lines is what's getting messed up. Because the fact that the Earth orbits the sun due to gravity, it's not that there's a force putting together as much as space is bent in such a way that we're just going to say the Earth rolls downhill towards the sun. Or when I drop a ball, it's not that the ball is being pulled towards the Earth as much as it's following the curvature of space. The classic way to view it is if you had a big rubber sheet, which is a weird thing to imagine you have, but let's say you have a big rubber sheet, and you put something heavy in the middle. If you put something in it, it would roll to the middle. That's the idea of gravity. Now, it's not, doesn't really kind of make sense because the whole idea of the rubber sheet, you know, I need gravity for it to roll down. And this isn't three-dimensional space, but five-dimensional space, which is really goddamn hard to comprehend. So I'm not going to go into too much details there, but that's the idea of what gravity is. It's that space is bent. And that the more massive something, the more it bends space. This video, which I'm not going to bother showing, it actually kind of quasi-explains it. This is my Physics 2 notes. Now, what this means is that space is bendable. This is going back to the port keys. Space can be bent. That the distance between me and you is, yeah, pretty set distance, but we can bend that. And all of space can be bent. Once again, we're working in 5 dimensions, so it's physically impossible for our brains to fully comprehend it. But space itself, she's looking so angry at me. Space itself can bend. So, if you want to hold more things in something, aka like Hermione's bag, or teleport, like the port keys, the idea is what you can do is you can bend space to make the 2 points touch. Interstellar, the movie, had a really good version where they showed this. Which, for those of you at home, will not be able to see what I'm doing, although well, that if this is space, if you want to get from one place to another, you bend the 2 points together. There's a classic book called The Wrinkle in Time, kids book. They explain it the same way in that. Wrinkle in Time, they go through this thing. That if you want to teleport, you take the 2 spots and put them next to each other. This is the idea of a wormhole. A wormhole in classic sci-fi is a spot that brings you from one spot to another simultaneously. And what it is that space is bent. This is what that shows you, is curved, space being curved, and a hole punctured in space in both places to lead to each other. So the idea of a port key, how it could work in the real world, theoretically, is you would bend space so the 2 points touched. And you could travel from one spot to another immediately just because those 2 spots overlap. Now, to do this, to bend space, well, bending space is very easy. Have mass and you're bending space. Space is bent around me because I weigh something. Lots of space is bent around Earth because it weighs more. Shit ton of space is bent around the sun because it weighs a lot. But to bend space in a planned way so that you can teleport, that's complicated. And not something that we obviously haven't put off, or else we'd be teleporting. But in theory, it's very possible. And there are some ideas on how to make wormholes be a thing of existence. The idea is they think black holes might be wormholes by nature because of the fact that they break space-time. And if they break space-time, there has to be leading to something. But yeah, in theory, that's how you teleport. You bend space around it. As I said, this is of all the ones, there's 2 of the things I worked out. The answers are very complicated. This is one of the 2 that's really complicated. Because you are literally bending space and time. But in theory, that's how you teleport. One of 2 methods of teleportation. There's another idea of how you could teleport, but this is the one that more matches what they do in the books.
So if your port key was a old junky boot, it'd be a junky boot with a lot of mass.
It would be a junky boot that would have a gravitational pull of a black hole. So you basically destroy the Earth.
I have the illustration from A Wrinkle in Time here. If anybody wants to see, I'll hold it up to the camera. I don't know if you have the camera anywhere that anyone can see.
We don't. It's on a different screen. They won't be able to see it.
Okay.
Wrinkle in Time does. Wrinkle in Time actually explains a lot of quantum physics really well.
Yeah.
Mm-hmm.
Which is funny because it's a kid's book.
Also, a commonly banned book.
Yes, it is. Yes.
That doesn't surprise me.
Is there an item for the
Side note, thumb notes just to Wrinkle in Time. Highly recommend. The wand? Wands are one of the ones I didn't really go into because the idea is the wand itself is a conduit for the magical forces. And so I went back and forth on what I was going to write for wands, and in the end, that's one of the few I left out because I don't view the wand itself as a device that's doing anything, but something that is channeling the magic. Now, the idea of devices in general that can channel something else, that's not uncommon. Hell, that's basically everything any piece of electronics does. But I can't do wand without going into magic as itself, and I'm just trying to say the effect of each magical device, so I don't really have wand worked out because it can do anything magic can do.
It's just too mysterious.
It is. It's one of the two that I don't have an answer for. I went through a Wikipedia page of every magical device, and those two I couldn't figure out.
What's the other one?
Hogwarts.
You should.
So the slide. The reason why we can't do Horcruxes is because it has to do with a soul, and then we get less. We get more religion, less physics.
What about the sorting hat?
Sorting hat's easy.
Why do they trust all of their decisions to a hat?
Sorting hat. Okay, sorting hat has three abilities. One, it talks, but I'm kind of ignoring that one for now, but I can go through it if you want.
Yeah.
Two, it reads someone's thoughts and tells them what school to go in. And three, you can pull a sword out of it, but that goes back into bending space-time and is the answer in the last one. Let's just do it knows what school to go in. Knowing what's the schools as they're described, basically, they try to put people of certain personalities in certain schools. Each of the schools have a theme going. Hey, you're evil, you're in Slytherin, that kind of thing. So the idea is it's something that sits on your head, why am I playing with that, and reads your personality. This is more bio than physics, so I can't go into detail, but that's a thing. So, there's a certain type of brain scan, fMRI, functional magnetic resonance imaging. That it's a brain scan that can see where different parts of your brain are firing.
Yeah.
And I actually read a few papers in preparing for this, and there's some early research. It's just starting now, but they think by doing this fMRI and seeing what parts of your brain scatter during certain things, basically they give you sort of little quiz stuff to look through. And what they found is certain personality traits and intelligence levels fire different ways. And so we actually have in real life a thing you can put on someone's head and figure out personality traits. That is a thing. As I said, it's very early on. Yeah. We can easily get images. That's what this is here. That's fMRI images. But right now, it is thought that we can actually use that to get, personality traits.
Is it the size of a hat?
It's like a metal cap with wires coming off of it.
Okay. So, sort of.
Yes, sort of.
It's hat-ish.
Although you might also, it depends. You might also have to do an MRI machine. So it's less a hat and more a bed. You can't move.
The sorting bed.
The sorting bed and not have anything metal on you. But there is some plans to make it more.
How much is the hat can be?
Well, as I said, this is all preliminary research, and this is much more bio, less physics, so slightly out of my area of expertise. Okay. But right now, we've long known how to see what part of the brain is firing using MRI. Yeah. And this is, as I said, a functional MRI. The difference is that it's doing it as it fires, watching it live, basically. An MRI is a picture. An fMRI is a video. Okay. And the idea is they're slowly discovering, well, they've known for a while what part of brains correspond to what types of stuff, but they're realizing that certain people with certain personality traits fire differently than other people. And so this can do a lot of stuff, as I said, certain personality traits. The paper talked about things such as, is it an outgoing person versus introvert, like extrovert versus introvert, that those people's brains literally fire different ways. And then from that, they can start getting base personality traits. It doesn't tell you what you're thinking, but just base personality traits. So yeah, that's the thing.
How about the letters?
The letters.
Yeah.
The ones that like speak.
Yeah, the speak. The one.
That's the easiest one. What you basically want is, I did the howl, is a letter that talks in the sender's voice. Any phone can do that.
But I mean, just like a.
You want it actually to physically
shape,
move?
Yeah, shape to
Okay.
mouth and.
So what you want is
airs.
paper that can fold itself like origami. Also exists.
Uh-huh.
Paper that can fold itself in certain ways have been starting to be made. The idea is, I didn't actually put this in the slide. I should have, because I didn't think of it. But this is a thing I've read about. Is that they've been making this smart paper that is really a bunch of really small things that hold electrical current that react in certain ways, and they have created paper that when you put a current through it, so you have to put electricity in it, but most all of these we're going to have to put electricity through them at some point, will bend in certain ways. And this is also another very preliminary, it isn't very far yet. The last time I learned about this, if you give me a second, I'll find out when this was most recently worked on. Smart paper. Oh, I want self-folding, I think. Self-folding origami paper. It's a thing. Apparently you can just buy it online now.
Wow.
How much electrical current would you need? Or
Oh, sorry, this is an article about it. This is one you can just buy. So yeah, Zhonghu University in China has been working on it. It works by heat and infrared lights. And it's graphene paper. So graphene, which is just single layers of carbon, has a whole bunch of weird electrical properties. The thing about graphene is, okay, graphite is a hunk of carbon. Graphene is a single layer of atoms. And it's actually neat because graphene, how it forms, exists in single layers. And what holds two layers of graphene together is less force than that of Scotch tape. I had friends who worked with graphene in grad school, and literally how you get a single layer of graphene is you take a block of graphite, and you put a piece of tape on it, and pull it off. And you can literally pull off an entire, and it will pull out exactly one layer of atoms. So this graphene can do really weird things with electricity, and the idea, and this is heat and light also, which is kind of similar in weird ways. And yeah, they can program in such a way with like basically microtransistors to bend at certain spots. So yeah, that's a thing too.
How about the stone?
The what?
The stone, the rare stone.
the sorcerer's stone.
Yeah.
Stone. The sorcerer's stone. What is it? I write that one down.
Yeah, it helps you make the elixir of life.
Ah, yes. There was a reason I skipped that one.
Because you can't sleep blood.
This gets a little crazy in itself because now we're getting to biology. The idea of ending aging. Once again, aging is something we've never mastered. I don't have a good answer for that one because, yeah, we age. Cells die.
What about snitches?
Oh, you just like this because I work this. I told you what I got from this one.
Or Quidditch in general.
Quidditch in general, I'd have to get into brooms. Let me do flying and then I'll do snitches. Okay. I'll put it together. Okay. Flying. So Quidditch in general. You need to fly. You're on a broom. The broom has to fly. Okay. I don't know why I'm not using my clicker. So there's a broom. Things fall because of gravity. If we go back to ignoring the Einstein gravity and the whole thing we talked about earlier, it's something with mass goes towards something else with mass. We're sticking Newtonian for now. It works good enough. Right? So there's a force of gravity, mass of the Earth. Once again, this isn't actually true, but if you pretend it's true, you get pretty good answers. Because Einstein makes no sense. What it is something called Newton's second law, which is actually what I'm teaching in physics right now. The sum of forces equals mass times acceleration. If you want something to stay floating in the air, let's not talk about moving up or down, but just stay magically in the middle of the air. That means it's not accelerating. That means A is 0. What that means is the sum of the forces must be 0. Now, if you have something on Earth, it's falling downwards, normally if it's in the air. That's because the force of gravity puts it down. My computer that's sitting on this table, it's not falling down because the table holds it up. Gravity pulls it down, the table pushes it up, they balance. If you need something to fly, you need a force up. You need something pushing it upwards. Now, and the magnitude of the force pushing up must match the weight. Because what weight is the force due to gravity on you. Mass is something different. So like kilograms, grams, mass, that's a whole other can of worms. But weight in pounds or Newton is yes, pounds and grams don't measure the same thing. Pounds and kilograms don't measure the same thing. That's a whole other can of worms. Yeah, you would need a certain amount of pounds pushing you up to counteract. Now, yeah, if you want to go upwards, it needs to be bigger. If you want to move downwards, it needs to be less. How things fly in general depends on the things. I talk here about birds and helicopters because I'm doing man-made. We could also do birds, but I'll do that more with bugs in the next bit. How planes fly is those wings are shaped such that they push wind downward. That when air goes over the wings, it pushes it down. And F equals ma is Newton's second law. Newton's third law is every action there's an equal and opposite reaction. If the wings push the wind down, the wind pushes the wings up. So planes or helicopters fly because they're pushing wind down and the wind pushes the thing up. Actually, birds do work the same way. So what you would need, because brooms have no wings, is you would need some sort of force on the broom pushing. Either a force from beneath pushing the broom up or a force on the broom pushing down. So to get something flying like that, you need to find, something to make a force out of. Easiest? Well, not the easiest, because they're all going to be deadly. The critical ones, easy way to get strong magnetic fields or strong forces, magnetic fields. If you have magnets with opposite poles, they repel each other. A lot of really the super trains that they have in Japan, they go really fast. The reason they go so fast is there's no friction. They're literally in the air, not touching anything, because the rails and the train itself are magnets repelling each other. So they don't have friction and rub, they hover above, but they go so fast. It's basically those super trains all flying. They're not touching, well, other parts of it do touch a little bit, but they're hovering above. Some really fast roller coasters work like this too. And so the idea is you could do that. Thing is, you'd be on the boom, you'd be near where the magnetic fields are. That type of magnetic field to lift you is enough to kill you, because the magnetic fields can affect electrical current. Our brains are based off electrical current. So that much magnetic field would fry your brain. Electric fields can also produce forces to do lift, so we could just do a strong enough electrical field. But if magnetic fields would mess up the electrical stuff in your brain, electric field would do so quicker. So the only other thing is we need some sort of lift force like a plane does. Basically, you would need wings. So if you want a flying broom, you can do it if no one's on it. It's easy if no one's on it. I can make a small one like light with a electromagnet if no one's on it. But if it's enough to support a human, it needs a lot of weight. It would kill it. Or you put wings on it. Now the golden snitch has its own way of flying because it has wings. And its wings look, I thought, a lot like dragonfly wings. So I compared it to a dragonfly. As you can see. Okay. Same idea, upward force. The wings push on the air, pushing it up. Dragonflies. The average dragonfly weighs 0.0001 ounces, and its wings are about 2.5 inches long. So each wing is about 2.5 inches. Now, what that means is a dragonfly wing of that size can lift weight. Let's say the golden snitch has about the same size wing, and it looks about right. You can see that this wing looks about the size of the width of a hand, which is about 2.5 inches. So theoretically, the wings on that thing can lift 0.001, that means 0.0001 ounces. That's doable, it seems. Here's the thing. Gold's heavy. Gold weighs 19.352 grams per centimeter cubed. And I'm assuming this thing's gold. I am also going to assume it's solid, which we know it isn't. We know it's hollow because there's like a stone inside. But let's assume it's solid because the math of shallows gets complicated, and trust me, it's not going to make a big difference. If it weighs 0.0001 ounces, which is 0.00283 grams, due to the density of gold, its volume would be this number right here. And if that's solid and it's a sphere, that accounts for a radius of 0.0327 centimeters, which is smaller than 1 grain of sand. Literally, dragonfly wings could only lift a piece of gold smaller than a grain of sand. Other than that, it would not be enough weight. It would not be enough lift for the amount of weight. Now, if you were to say, okay, let's figure out how big the wings would need to be to lift something the size, I decided to use, actually, I think you decided to use, but I went with the golden snitch inside of a golf ball, which actually might be a little small. If this scale, which it doesn't scale, but if it scaled that if we multiply the volume by that much, how big would the wings get? By the way, I say it doesn't, this number is going to be small. Because it doesn't really scale, because also the wings weigh stuff and some other issues, that if I say it scales and I find the size of the wings, that's too small. The wings would have to be bigger than that. So if it's scaled, so this is the very bottom possible, a golf ball sized piece of gold would weigh 6,311 grams. And if it's scaled, that would result to a wing, each one 87.8 miles long, each one. Now keep in mind, this doesn't scale. So really, they'd be probably near twice as long each one.
So you'd never not be able to find the golden snitch.
It would be easy to find because it would be many times bigger than the field. Or it will be that smaller than a grain of sand. One or the other. So yeah, it's a problem. There's also another problem with the golden snitch. It has randomized movement. Random is really hard for computers. Computers can randomize theoretically, but how they do randomize is a weird algorithm. If you do like iTunes and put it on shuffle, how it never seems random, it always seems to play some songs more than others. That's because computers cannot do pure random. Random number generators are a thing, which I think I wrote right there. They're all algorithms that approximate randomness, but it's not pure random because it's figured out by an algorithm. So the idea of something completely going random directions is impossible. It can just get really close that you won't be able to tell the difference. Problem with computers. Was that? Yeah.
What about the cloak of invisibility?
Cloak of invisibility.
Cloak? That cape that makes you invisible?
I try to say that too, yeah.
That one's one of the ones that we are closest to having exist in the real world.
Yeah.
And have some of the biggest problems with, because people are actually working on this. Most science funding, especially in physics, is paid for by the government.
Yeah.
The government pays because they want military reasons. So the idea of making people invisible makes the Army, Navy, Air Force, etc. very excited for obvious reasons. So a lot of money is dropped into making things invisible. Like, this is something that a lot of money goes into. Now, light. I need to talk about light. Why you can see something is light bounces off something and hits your eyes. Right now, you can see me because light from these lights and from outside is coming from those sources hitting me, bouncing off me into your eyes. And your eyes interpret that. For something to be invisible, well, there's the cheating way and the more realistic way. The cheating way is, if you ever watch Avengers, the first Avengers movie, the ship goes invisible. There's those cameras on the top and screens on the bottom. So it's just recording what's on top and live displaying it on the bottom. Oh, that's the cheating. If you want pure, real invisibility, what you need is that when the light comes at something, it doesn't bounce off it, but goes around it and comes out the other side like it isn't there. You need to like the code. So this is pretty crazy. This group in England, which there's a link up here with to the paper. But here's the idea. This group in England made a cloak, an actual piece of fabric that consists of nanocomposite little particles. And each one of these little nano pieces has a different index of refraction. index of refraction is how much light bends when it hits something. And what they did, this is kind of crazy, is they put something round in the middle, right? And looked at the light waves as they hit it. This is the bottom left picture. And what you can see is when the light hits something round, it bounced off in real waves. They then put their invisibility cloak on top of the round thing and had light hit it. And as you can see in the right picture, the light is uninterrupted on the left, well, uninterrupted middle. But what it was doing on the left is the same as what it's doing on the right. Basically, this cloak, which you can imagine is basically made out of a ton of very, 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 very small pieces of glass of different types. It's not really what's going on, but it's kind of a way to approximate it. That when light hits it, it bounces around in it and follows the pattern of the cloak and comes out the other side exactly how it is. They have made a cloak that does this. It's not very big. It's about yay big. I think it's something like 2 centimeters cubed, or 2 centimeters squared.
So it's really more of a finger cloak.
Yes. But it is something we're working on, that science is working on, and they're pretty close. There is a huge issue with invisibility cloaks, though, which is written right there. You see, how you see is by light hitting your eyes. If we make it that you can't see me, that means light gets near me, goes around me inside. If the light doesn't hit my eyes, I can't see. If you're invisible, you're blind. Because invisibility means light waves aren't hitting you, they're going around you. Light waves aren't hitting you, they're not hitting your eyes. So anyone who's invisible is blind. Not just like, oh, it's dark, pure blindness, because no light will be hitting them. That's kind of a drawback.
Yeah.
The only workaround is there'll have to be a small piece that isn't invisible, but then again, if you make everyone invisible, but like, except like a slit for their eyes, still a lot more. Also, this cloak thing, once again, needs a large amount of electricity running through it. It is not zero power. Once again, that's going to be our version of magic is electricity.
So do you think wizards have just figured out super electricity?
We can go with that.
So it's possible that we can remake a kind of magic school. Like
Yeah.
Those,
Well, I mean, the amount of things you can do with the amount of things you can do with technology are pretty amazing. And so most of the stuff that are in the books, there is a version of reality, just because of the fact that with what we already have and technology we're working on, there are ideas how to do it. And the thing is, with a book like that, a lot of scientists are real nerds. So when something comes up in a popular fiction, a lot of people will just take that as a reason to try to make it. One good example is in one random Star Trek movie, they mention transparent aluminum. There was these people who made it their life goal to make transparent aluminum a thing just because it was in a Star Trek movie, and it succeeded. Transparent aluminum is kind of a thing. It's a little more complicated than that, but they made a version of aluminum that light can go through.
Is it strong enough to
I don't know if it's strong enough to contain space force. And so the idea is a lot of the stuff from things like Harry Potter, people make effort to make just because it's the type of thing. Or in the case of this, it has, military purposes. Well, if you want money for research, you need to somehow make them think the military think it's worthwhile. They, in America at least, they're the biggest givers of money for research.
without talking painting? Sentient talking painting.
What's that? I can do talking paintings. Sentient talking paintings? Then what part of it's sentient? Here's the thing. A talking painting really, the idea of a big difference between a painting and a picture isn't much. So you could argue that a talking painting, I can just put an iPad on the wall.
A computer.
Yeah, you can just do it with a computer screen.
Yeah. That was easy too. I think that the whole is easy to learn.
The what?
The whole, the fortune telling, used for fortune telling.
Oh, the crystal balls.
The crystal.
Oh,
so you can
yeah.
also put it on screen and
The crystal, yeah.
machine.
The closest I did to writing out the crystal ball, because is what I thought of, was what's that thing called? Illuminator faux glass. Yeah, they have like the faux glasses, which is the thing Moody looks in a crystal ball to see if anyone's approaching him. It's just like, it's the same as a computer screen and a security camera. Anything like that where you just want to see things elsewhere, that's easy for us to do. You have to put a camera there, but the amount of size a camera takes up these days, it is not hard to put a camera if you need somewhere.
So what else do you have in your slide?
I have a question. Do you have
Yeah.
the put outer?
The what?
The put outer that takes the lights from the street lamps?
The illuminator.
The illuminator, yes.
I probably should open that video, but I'm not going to bother. So one of the main things they use the illuminator for is streetlights. Streetlights are the easiest thing in the world to turn off. You can turn off any streetlight in America with a laser pointer. Okay. Streetlights only work at night. They're off during the day. The reason for that is they have photodiodes. You see a streetlight on its top has a little piece that acknowledges how light it is. A photodiode is a thing that it's a switch that if light is hitting it, it's on, it's off. If light isn't hitting it, it turns on. Oh no, it goes the opposite way. You can still work it out. So what happens is if it's sunny, the streetlight turns off because light is hitting the photodiode. If it's dark, the streetlight turns on. There's no lights hitting it. If you go to a streetlight, like any streetlight, and shine a laser pointer at a little spot on the top, it will turn off. If you YouTube this, you'll find a bunch of people who are angry that they have streetlights outside their windows and made whole setups with just a switch with it aimed correctly, so they have a switch to turn off the streetlights outside their house. Found a whole bunch of YouTube videos that did that. This one here, which here we're gonna minimize for a second. Actually loading, or is it going slow? So we have some of the street light, and if you watch the pointer coming across, and right when he hits the right spot near the top, turns off.
This is fascinating and potentially dangerous information.
So really all Dumbledore needed was a laser.
Now, it wouldn't do the crazy thing where the light goes to the thing, but yeah, you want to turn off a street light, just shine a laser pointer on it.
Is this for the make a machine, like screen, like make a screen like paper, like the newspaper in Harry Potter?
Oh yeah.
Yes,
You see that
there
people
is,
moving
as
there
of
and,
now, we haven't quite gotten that, but I mean, you can buy bendable phones, right?
How big, how strong we can make a machine?
Right now, not very thin.
Not very.
And the bigger issue is more like an LCD screen is small. Having it, or thin, I mean. But the problem is that because it's really bendable. We can get screens thin. I mean, think about it just with a phone, and my phone's going to look a lot thicker than it is because of but most of the stuff behind is electronics. The idea of a bendable phone is already a thing. I forget who has it. I think I want to say Samsung has a phone that bends really far, like flexible. And this is one of the things that technology is always improving on. So we're getting thinner and thinner. I don't think it'll ever, the problem is, I don't think it'll ever be useful as paper because then it would have to be, cheaper than paper. So it doesn't really seem worthwhile. I mean, even people sometimes still going and putting colored copies on stuff because it's more expensive. But the idea of bendable screens is something that's happened. I saw something about a rollable screen not too far away. It can't bend in half, but you could roll it because it was bendable enough. Mostly with LCDs, because LCD stands for liquid crystal display. It's a liquid, so it big shape. The problem is it's only held by glass. But yeah, that is something that does exist. As I said, I don't have the exact details on that one just because I didn't think of that one to prepare it. But so I don't have a slide explaining it exactly. But that is a. Amanda, do you have any you want to see?
The mirror.
The mirror. The mirror lets them see what they most desired, what they wanted.
Oh, that one. And also, there's a man killed by witches and being lured to the mirror. the mirror?
So the problem with the mirror knowing what you want, that one's hard because that gets into mind reading again. We can read personality traits, we can't read thoughts. So I don't have something for that. That being said, making it display whatever the hell you want, well, that's once again one step away from having the mirror double as a screen. And so many people use screens as mirrors as is. I see so many people in my class fixing their hair by using their phone on the camera mode.
Yeah.
So the idea of having something that interchange become a mirror and a screen is real. The problem is reading your thoughts.
They do have, they're piloting them in a couple of different halls.
Oh,
how you physically
well, it has basically there's something called black radiant. Right now you are radiating heat, and different parts of your body radiate different amounts. Heat can be seen by a and the camera in the camera that hooks up to an Xbox see enough of a range. It can, or in the info that looking at you, it can see where your heat is and figure out your heart rate. So that can tell if you're how quick, if you're, you know, your blood is really pumping or if you're more relaxed. It can do it just looking at you without anything else. So that can give a little bit, because heart rate does tie into some stress, fear type things, the idea of a camera that can look at you and see how freaked out is doable. Past that, if it wants to do you fear, it can try, there's a lot of facial text that things can read, and software that can look at your face and figure out, you know, are you smiling or upset? Once again, that's simple, that's just a camera videotape. But actual heart rate is also doable with cameras, just by seeing where, how hot you are, for that comparison. I was actually really amazed when I learned that connecting with your blood rate and figure out your heart rate.
Okay, thank you very much.
No problem.
I have one more.
Sure.
I can sort of think of how the Marauders map might work, but does that mean that everybody in Harry Potter universe is RFID tagged?
Yeah, it does.
Would that be the other way? Do
you want to know what would be really easy? You want to know how you RFID at school and very easy though? Put it in the ID. Put an RFID chip in the school ID, and there you go. You can instantly figure out where everyone is at all times.
Great. Just what we need.
I mean, that picture there was the size of an RFID chip compared to a grain of rice.
Rice, yeah. I mean, they're in all of our library books, so we don't have it enabled, but some libraries that have the same kind of security tags that we have in those books out there on the shelf could theoretically track wherever those books are on campus.
Yeah. And that's what a microchip in a cat is. If you get a pet microchip, it's an RFID chip. And it's kind of interesting. I didn't know much about RFID chips, so I prepared for this. There's active and passive ones. Some of them are perpetually emitting. Other ones just collect data and only respond if you ping them. If you put an active one, which they don't take much power, it would be at all times displaying. A passive one would just be whenever you hit the search button, it would show up. It wouldn't be continuously moving. You'd have to, unless you set the program to be continuously searching. But you could press a button and beep, 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 see what every person's ID is, unless you actually are microchipping people, which most schools would probably get in trouble if they tried to microchip the actual students. That being said, that's the biggest issue, is you'd be tracking people, and there's a large number of people, which probably rightfully would not be happy knowing that the school can watch their every movement. But yeah, it's really easy to do that with RFID chips.
Right. And we talk about it in libraries, because if your library books had in them. Sorry, can you hear me?
Yeah, I can hear.
We've talked about it in libraries as an issue, because if your books had it, then whoever's got that book, you could theoretically see wherever they were, which would not be such a great thing for privacy.
No, that's the biggest problem with RFID. But I mean, when you think about the Mottos map in general, it's a huge privacy-breaking thing
Yeah.
because they'll instantly knowing where everyone is. Isn't that the one thing with those like two people in the corner that the feet kind of overlap in a weird way? You know, you'd
Maybe they were standing on top of each other trying to reach something on a high shelf.
yes.
Don't know.
But yeah, no, it's easy to track people.
Well, thank you, Dr. Schweidenback.
No
Yeah, this
problem.
was great.
Yeah,
Happy Banned Books Week.
yeah. Do one more. Time tunnel. Okay. Time travel I can't do. Time travel gets weird. And it's theoretically possible to time travel if you move faster than the speed of light, according to the math, but we're not going to deal with that. We're going to get hit the speed of light but not pass it. But slowing time is very easy. You see, we're three-dimensional people. Time is the fourth dimension. And that whole space-time thing that was in the fifth dimension. So the idea is moving in time forward and backwards, pain in the ass. We're not going to worry about doing that, but just slowing time. Slowing time such that Hermione could go through a few days worth of time in one class period and run around from place to place. Very feasible. Here's the thing. Light has a set speed. Light moves at the speed of light, aptly named, which is 3 times 10 to the 8th meters per second. One of the other things Einstein said, because this is still Einstein, is that light always moves at that speed in all reference frames. What I mean, and do I say it here? Not really. Let's say I take something, let's say I'm in a car driving, and I throw something straight up and straight down. If I'm in a car and throw something straight up and straight down, to me it looks like it goes straight up, straight down. If you're standing to the side, it'll look like it went up and forward, then down and forward, because it'd be moving with me in the car, right? That means 2 different distances and 2 different times. Light always moves at 3 times 10 to the 8th in all reference frames. Here's even a better explanation. If I run forward and throw something as I run forward, and you're standing still, you would think the ball is going faster than I would, because it would be my speed plus the ball speed. I would just say the ball speed. If I'm moving at almost the speed of light, to shine a flashlight, you would see the light leave the flashlight at the speed of light. I would see the light leave the flashlight at the speed of light also. The problem is, it would look like to you that the light is only moving a little bit faster than I am, because I'm moving the other speed of light. To me, it would look like the light is shooting off at the speed of light. So, let's say we had a boxcar in a train. Someone has a light, they're shooting up off a mirror, back down. They see it go up a distance d, down a distance d. So in subset time, it moves 2d. Now the boxcar is moving forward, and someone's watching it. And they see in the set time that it comes up over here, then down back over there. So in that same time period, they see it move a different distance. Make sense what I mean so far?
Mm-hmm.
Now, both people see light moving at the same speed. They both think light moves at 3 times 10 to the 8th meters per second. So we have 2 people who see light travel 2 different distances, but both with the same speed. Now, since distance is speed times time, that means if it's traveling at the same speed but a different distance, it must be traveling for a different amount of time. So the time it takes the light to go up and down is different for the 2 people. Now, this at this point is all like seems conceptual. But the general idea was, in general, time is relative. That how long 1 second takes depends on how fast you're moving. Time is completely dependent on speed. Now, jumping past the twin paradox for a second, did I put it on there? It's at the end of the twin paradox. Okay, let me do one more slide and I'll go through it. This is the idea of the twin paradox. This is stolen from a textbook, and they use the names Speedo and Goslow, which I think is the funniest thing ever, so I'm using those names. So we have 2 twins, the same age.
Who are in a circus.
Who are in a circus. One of them lives on Earth. The other one travels 20 light years away at a speed of 0.95 times the speed of light. And so he travels for 20 light years, which 20 light years, it means he's actually going to travel for a little longer than a year. So he's going to travel out 20 light years, then back 20 light years at 0.95 C. That's going to take 2 years for him to do, because it's not at C, it's at 0.9 whatever C.
Mm-hmm.
So the guy on Earth, 42 years has passed between his twin leaving and coming back. The guy who traveled at 0.95 C, he only sees 13 years pass. So now the one twin is 30-something years younger than the other one.
So it's like what they talked about in Interstellar.
It's like what they talked about in Interstellar. Interstellar has a lot of good science. And the thing is, this all seems incredibly weird conceptual, but when they put really, really, really sensitive clocks on jets, that with the speed a jet moves, there is a noticeable time dilation. That when you're moving on a fast jet, time moves slower for you than people on Earth's surface. So the process of driving home in your car, you will be moving faster than someone stationary. So time will move slower for you than someone sitting at home. The thing is, that's barely moving fast enough. That's not moving fast to get a negligible difference. But if, once again, a commercial jet traveling will lose a fraction of a second only, but moving at those speeds, time moves slower. And it's all based on the fact that light is the same in all weapons space. Oh, light causes also problems.
Maybe it's not black holes. I hate it's light.
Fun fact, all of these slides and the slides related to the port key were all from one lecture for physics 2. That was called the lecture. I think that lecture opens with a slide like, today I blow your brains. Because it's a crazy lecture. Well, it's a crazy chapter. It's one chapter. It might have been 2 lectures. But yeah, time slowing down is really easy. All you do is move quickly. The quicker you move, the slower time goes. The enchanted coins was ferrofluids. Ferrofluids are a thing. They're an awesome thing. They're one of the coolest things in my opinion. It's a fluid that's affected by magnetic fields. And you can actually make the fluid make any shape you want just by changing the magnetic field, because you can control a magnetic field with electricity. This thing here is people just playing with fun magnetic fields on this drill bit to make a crazy shape. So you can actually make the metal say whatever you want with ferrofluids. The problem is it's a fluid, so if you put the coin in your pocket, it will rub off. So you kind of have to put a case around it so it doesn't rub off. But making the coins change what's written on the side is very possible.
Right. Well, I feel more informed about the magical world of Harry Potter.
You should. Yeah, it's 5:30 now. All right. I guess I'll call it a day there.